Drawing the graphs or charts can be done using Matplotlib package. The same thing can be done using Seaborn package also. Seaborn is a wrapper around Matplotlib that contains more advanced features. This is the reason most of the times when we use Seaborn, we will also import Matplotlib. Seaborn offers beautiful soft colors and use simple and short syntax. Seaborn is also faster than Matplotlib while rendering the graphs. Coming to the installation of Seaborn, you need to execute a command pip install Seaborn. So let us execute pip install Seaborn. So let me write the command pip install Seaborn. So currently in my system it is already installed, so requirement already satisfied I am getting. But if you are not installed Seaborn, then Seaborn will install into your Python environment. So this will install Seaborn package from the internet and install it as a module in your Python software. Once you have installed Seaborn, you can go for plotting various plots. Now let us see how to import the packages. So let me just minimize this terminal. I'll just scroll down and you can see the Matplotlib package we have imported as PLT, and this Seaborn we are importing as SNS. SNS is basically allies to Seaborn and PLT is allies to matplotlib.pyplot. So let's execute this. So the package has been imported. Now let us talk about datasets. If you have dataset available in CSV file or Excel file, you can load a data using pandas. But currently for this tutorial, what I'm doing, I am just taking a dataset from Seaborn library itself. So to load a dataset, there is a function named as load dataset from SNS, that is Seaborn, seaborn.load datasets, and this is the name of dataset basically, MPG, that is mileage per gallon, and load this dataset and keep into this particular data frame df1, and let us print the df1. So let me just execute this. You can see this is the dataset available. So we have 398 rows and 9 columns. So the first column is MPG, second is number of cylinders, third is displacement, fourth is horsepower, next is weight of the car. This is basically car dataset or automobile dataset, and next is acceleration of that particular car, model year, origin of that car, and the name of that particular car. So if you want to display which are the columns available, just write columns. So you have this particular columns: MPG, cylinders, displacement, horsepower, weight, acceleration, model year, origin, and name. Now let us display some information about df1. So df1.info. So info is a function which will show little bit information about data frame. So we have total 398 entries. Indexing starts with 0 to 397. Total 9 columns are there. These are the 9 columns, and you can see in all the columns we have 398 values. So there is no any missing value. So these are not null values, and you can see the data type of each value. MPG is present in float format. Cylinders are present in integer format. So this, how many number of float values are there? That is 4. Number of integer values are 3, and the object value is nothing but string value. So origin and name is present in the text format. And currently this dataset has taken, the internal memory is around 28 KB. Now let us talk about distribution plot. So distribution plot is normally used for univariate analysis as well as bivariate analysis. So I will show you both the ways how distribution plots can be used as a univariate analysis and bivariate analysis. So let us discuss first. Distribution plot represents how data is distributed at certain intervals, and these intervals are called as bins. And to use or to create distribution plots, we can use a displot function available in SNS. So you can see seaborn.displot function we can use. So we have already imported Seaborn as SNS. So seaborn.displot, and the first parameter attribute that we are to supply, that is data frame name. So data equal to data frame name. So our data frame name is basically df1. So pass df1, and we want to see the distribution of which variable. So we have 9 columns. Out of that, let us see, we need to check the values, the distributions of the values present in cylinder columns. So the x is basically x axis, and that we are choosing as a cylinder. And also we need to pass bins. So currently we have set bin as a 5. You can change the bins, depends on you. Then we will have x axis, so we can give x label, number of cylinders, and we can show the plot. So this PLT is the alias for matplotlib.pyplot, and SNS is the alias for Seaborn. So let's execute this, and you can see, so this is the distribution plot for a cylinder column. And from this, you can see the number of cylinders comes to the x-axis, and the count of the car, right, present is presenting this particular y-axis. If you observe this graph very carefully, so we can say that more number of cars, right, are using this particular 4 to 5 number of cylinders. So 3 to 4, right, 5 to 6, and even 6 to 7, 7 to 8, they have certain number of cars. But the highest bar is this. This is called as bar, just like a histogram bar. And the number of cylinders are present in that, though more number of cars is basically in between 4 and 5. Even you can display the kernel density estimate line along with histogram. So to use this kernel density estimate line, we can use this particular parameter KD equal to true. So in the same code, if you are going to add one more parameter KD equal to true, in that case we don't have to use bin parameter. So you can see SNS.displot. This is the data frame name. X is basically cylinder. Number of so number of bins is 5 because we want to display histogram also, and KD is also true. So let me run this now. If I'm running this, so this is the KDE line. So you might be thinking, what is KDE line? KDE line is basically a smooth line that represents overall distribution of a data, and it shows basically density level. And even if you want to display only KDE line without histogram, that also we can do. And to do this, what we can do, we can use this kind parameter, kind attribute. So SNS.displot, this is the data frame name. X is basically my cylinders, number of cylinders. The kind equal to KDE. If you are going to do this, then only KDE line will come. Bars will not come, right? So let me execute this. So you can see the number of cylinders. This is basically KDE line. And I already talked about KDE line. KDE line is a smooth line which represents overall distribution of a data. And in this case, you should not use the bins option. See, here we have removed the bins option. So because we don't have a histogram, we have only KDE line. So bins options we have to remove from here, and the kind parameter, kind attribute, we have to set as a KDE. So we'll get only distribution line. Sometimes if we want a proportional densities, then we should display empirical cumulative distribution function by writing kind equal to ECDF. So same code, what I will do, instead of KDE, we can write ECDF, and ECDF stands for empirical cumulative distribution function to get the particular ECDF graph. So instead of KDE, if we are going to give ECDF, let me execute this. So this will show the proportional densities. So this starts from here 3 to 4, then number of cylinders 4, more number of cars are there, so it goes up to here, then it goes to this place. 5 number of cylinders are less, so that's why this bar is less, this height is less. Then it goes to the 6 are a little bit more compared to 5 but less to 4, that's why this length is more than this length but less than this length, and so on. So this is called as basically proportional densities. If you want to get proportional densities, then this kind parameter we can choose as a ECDF. ECDF is basically standing for empirical cumulative distribution function. So this is the way using which we can go for univariate analysis, and we can do the univariate analysis with the help of distribution plot. Now, how can we go for bivariate analysis, and how we can use distribution plot to get or to do the basically bivariate analysis? So let us go down. So distribution plot for bivariate analysis, and we know already what is bivariate analysis. If we want to show the relationship between two variables, then that kind of analysis is called as bivariate analysis. And we can do this using distribution plot also. So let's plot the distribution plot for two variables. The first variable is basically number of cylinders that we have already done the unit analysis on this variable only, which is on x-axis. Also, what we will do, we will choose one more variable, that is mileage, which is present here. Let me show that data set to you. Yeah, so this is the first MPG, this is the first variable. Now we will choose this as x-axis, this will be y-axis, and we will see the relation between these two using distribution function. So let me go down. Yeah, so on mileage will be on y-axis and the number of cylinders will be on x-axis. So how to do this? So the same, we can use the same function, displot. The data frame will be given as a data. X will be basically cylinders, the name of cylinders column, that is cylinders, and Y will be basically the first column, that is MPG. And currently we are having two axes, X and Y. That's why we can pass X label also and Y label also. That's optional basically, but we can pass. Let me run this, and this is the basically a distribution plot for bivariate analysis. And here on x-axis we have number of cylinders and y-axis we have mileage per gallon. And by observing this graph, we can see this is the longest bar. So we can say that from the graph, we can say that maximum mileage given by the cars are having how many number of cylinders? 4 number of cylinders. So this is the conclusion we can draw from this particular distribution plot, that is bivariate distribution plot. Also, we can do a KDE line. We can draw a KDE line for this bivariate analysis. So let me, if you want to display the KDE line along with histogram, right? Because histogram is not displaying, we are here. So to display KDE line, we can use this particular parameter, KDE equal to true. Not KDE equal to true, basically it's a kind equal to KDE. So kind is equal to KDE. So if say in this particular code, Seaborn dot displot, data frame is given as a data, X is my cylinders, Y is my mileage per gallon, and kind is equal to KDE. This X label is number of cylinders, Y label is my mileage per gallon, and we are going to run this. So you can see, so this is the basically KDE line, that is kernel density estimate line for bivariate analysis. And you can see again from this particular graph, we can say that this KDE line is big. So we can see the same conclusion, right? The maximum mileage given by the cars has how many number of cylinders? 4 number of cylinders, and so on. I think that's enough for this video. So let's recap in 2 minutes what we have seen in this particular video tutorial. So we started with Seaborn. So we have installed Seaborn package and we have imported Seaborn. We have loaded a dataset which is present in Seaborn, and we have gone for distribution plot. So distribution plot is mainly used to show the distribution of a data. And we have seen how distribution plot can be used to do univariate analysis as well as bivariate analysis. So that's it for this video. If you found this video useful, you can like, share and subscribe the channel. Thanks for watching this video. Thank you.